Alright, welcome to my channel. My name is Victor. Welcome to Victor's Maths channel. Today we'll be considering the cosine rule, when and how to use it. Alright, now this is the cosine rule. Looking at this triangle, we apply cosine rule to solving triangles when we have 4 parameters under consideration, 3 sides and 1 angle. And this is a typical way of labeling a triangle where we have angle A facing small side A, angle B will always be facing the small side C, and then angle C facing the side with small c. Alright, so these are the 3 formulas for finding sides. In the case of the first one, we apply it basically when we're given side B, side C, and angle A. But for the second one, it's easy to use when we're given the side A, C, and the angle B in the triangle above. And then for the third one, it's easy to use when we're given side A, B, and angle C, the triangle above. Now, this formula can be rearranged in order for us to get the formula to easily find angles. So when we rearrange equation 1 such that we make A the solid formula, and equation 2 we make B the solid formula, and equation 3 we make angle C the solid formula, we're going to have these 3 formulas here. Alright, respectively. So for 1, this will lead to 1, this will lead to this equation 2, and equation 3 above will lead to this equation 3 below. Alright, so let me just explain how we derived equation 1 only, and that's knowledge also you can transfer to get equation 2 and 3 respectively. Okay, let me just start with rewriting the cosine rule finding side A. All we have to do here is just to transfer A squared to the right hand side and minus 2bc cos A to the left. So due to that switch, the signs will change. We're going to have on the right, joining b squared and plus c squared will be minus a squared, and coming to the left will now be positive 2bc cos A. Alright, so dividing both sides by 2bc cancel out 2bc on the left, so cosine of A, the cosine of A is equals to b squared plus c squared minus a squared over 2bc. Okay, so we can adopt this idea to establish other ones. So you can see now, this is what we just derived below here. Alright, now cosine rule is more encompassing. It allows you to incorporate more parameters and then to find an angle if an angle is missing in a triangle, any triangle, unlike the Pythagoras rule, which is limited to finding 3 sides alone. I mean, to consider just 3 sides of a triangle when one of the sides is missing. And one other thing is that Pythagoras rule is limited only to right angle triangle, like we have here now. This equation 1, 2, 3 will reduce to a particular form because of cosine of A, cosine of B, cosine of C being 90 degrees respectively in this first, second, and third, so that when we have such a situation, this will vanish because of cosine of A is cos 90 to affect the whole of the third term on the right hand side. The same thing goes with this cosine of B, which is cos 90, will make this third term on the right hand side with 0. Same thing goes with this. So these 3 formulas will reduce to this form if you are dealing with a right angle triangle where A is 90 and where B is 90 and where C is 90 respectively. Alright, so cosine rule is more encompassing and allows you to solve for more parameters. Okay, now let's see this. All right, let's see an example here. We are to solve, so find the side opposite to angle B to the nearest three significant figures. Now looking at angle B here, based on our typical way of labeling triangles to apply cosine rule, before we can apply cosine rule, angle B must be facing small b, so I'm labeling that side as small b. Angle C must be facing small c, and angle A small a, for easy application of this cosine rule. Now in this case we're looking for the side B, so I'm going to use the second formula for finding sides given in the round, which is b squared equals to a squared plus c squared minus 2ac cosine of b. Okay, now let's substitute our values. A is 30 and that will be squared. Okay, c is 20 to be squared, then twice 30 times 20 cosine of angle B, which is 95 degrees. Okay, moving further, 30 squared is 900, 20 squared is 400, so when we add 900 plus 400 we have 1300. 2 times 30 times 20 will give us 1200. Then cosine of 95, using your statistical table or your calculator, you're going to have the answer to be minus 0.0872. When we multiply, don't forget this b squared, when we multiply your minus 1200 with minus 0.0872, we're going to have positive 104.64. Alright, when we add up 1300 plus 104.64, we're going to have 1404.64. That's b squared, and at this point we can take the square root of both sides, so your square cancel out the square root here. So b, the square root of 1404.64 is 37.478 meters. But the question says that we leave our answer to the nearest three significant figures, so definitely we're going to count 1, 2, 3. But before we write the third one, we use the 7 to round off 4. And the kind of round off here is not a round down but a round up. So we're going to add up 1. We're going to add 1 to 4, so we're going to make it 5 meters, 37.5 meters. This is to this degree of accuracy, it is to 3 significant figures. Now let's see one more example before we wrap up. And example 2. This triangle has been labeled typically also. Angle X is going to be facing small x. I'm going to label that as small x. Angle Y will be facing small y. And angle Z will be facing small z. Alright. Now, I typically give this example because just to avoid us being fixated at all the time we must have A, B, C. No, we can look at how we're going to change all the sides here. A will change to X, then capital B will change to Y, and then capital C will become Z. And then labeling our sides here A, B, and C, such that anywhere we have small a becomes small x, small b becomes small y, and then small c becomes small z. So now using the formula for finding angles, when we are looking for angle x now, but let us start with angle A first. Using that formula given earlier on, cosine of A will have this format: b squared plus c squared minus a squared over 2bc. So I'm going to change x, y, z to a, b, c. So definitely our cos A will become cos x, b squared will become y squared, c squared will become z squared, and a squared will become x squared. Then 2bc will become 2yz. Alright, so the question says find the angle x in the diagram above to 1 decimal place. Alright, to 1 decimal place. So let's substitute our values. Cosine of x is equals to the y given to us here based on our labeling is as 4 squared, and then the z we've labeled as 5 squared, okay, minus x is 6 squared whole over 2 times 4 times 5, okay. 4 squared plus 5 squared, that's 16 plus 25, that's 41. 6 squared is 36. Alright, 2 times 4, 8, 8 times 5, we have 40. 41 minus 36 is 5 over 40. When we simplify, we have 1 over 8, because 5 cancels 5, give us 1. 5 cancels 40, we have 8. We convert this to decimal, we're going to have 0.125. Okay, so cos x is 0.125. At this point, we take the cos inverse of both sides. In other words, we divide both sides by cosine, or you say multiply both sides by 1 over cos. Anyone? Alright, this cancel out this. We're going to have angle x. Now, we're going to write 1 over cos raised by 1 as cos raised by minus 1. We call it cos inverse of 0.125. Reason is because in algebra, the same way we write x raised by minus 1 and also 1 over y raised by 1 as y raised by minus 1. The same approach we have used in writing this. Alright? Okay? So now using your Pythagoras table, your statistical table, or your calculator, when you check the cos inverse of the cos inverse of 0.125, the answer you're going to get is 82.819 degrees. And then don't forget we have to approximate our answer to this degree of accuracy to 1 decimal place. So using that means a digit just after the decimal, just 1 digit after this decimal. So we have 82 before, then after the decimal, before we write this 1 digit, will 1 round this up, will 1 round it up or down? Definitely round it down because it's less than 5. So, and it's not even up to 5. So we add 0 to 8, we have 8. So the answer here for angle x is 82.8 degrees to 1 decimal place. Thank you for watching, and then please don't forget to subscribe, share, and make a comment. Thank you so much. I appreciate your support.